Good day, viewers at home. This is on geometric progression. Previously, we talked about arithmetic progression. So this is geometric progression. This is when you have a sequence of numbers in which you are to multiply each term by a particular number to get the next term. For instance, look at this series now. 2, 6, 18, 54. 2, 6, 18, 54. If you observe, if you multiply 2 by 3, you get 6. If you multiply 6 by 3, you get 18. And if you multiply 18 by 3, you get 54. And it continues like that. So we can say this is a geometric progression. Since it follows a particular pattern and we have a definite number that we can multiply by a term to get the next term. And like we have in the previous one, which is arithmetic progression, A is first term, like in AP2. A is first term. But the difference between arithmetic progression and geometric progression is here we don't have common difference. What we have is common ratio. We call it common ratio because if you divide second term by the first term, you will get the same thing as the third term divided by the second term, and it will be the same thing as the fourth term divided by the third term, and it continues like that. So that's why we call it common ratio. So n, like in arithmetic progression, n is number of terms, and n is also used to denote last term. So how do we get nth term, like fourth term, fifth term, eighth term, like that? For us to get the nth term of an arithmetic of a geometric progression, we use this formula: AR n minus 1. AR raised to power n minus 1. That is, our A is the first term, our R is the common ratio, and n is the number of terms. Let's take this geometric progression for example. If we are to get, let's say, the eighth term of this geometric progression, our A is the first term, which is 2. Our R is the common ratio, and common ratio is what we have here. 6 divided by 2 is 3. Raised to power n, our n is 8, since we are looking for the eighth term, minus 1. So that is 2 times 3 raised to power 8 minus 1 is 7. So if you look at this figure, sometimes if you want to expand, it gives you a very large number. So it is advisable sometimes to leave your answer in index form when the number is going to be too large. Let's take another example on nth term. Another example of nth term. The first term here is 16, second term is 8, third term is 4, 2, 1, and so on. Here we can see that our first term is 16. What is the common ratio? Common ratio is second term divided by first term, or third term divided by second term. So if I divide 8 by 16, 2, I have 1 over 2. So my common ratio is 1 over 2. So in this case now, if I'm asked to find, let's say, fifth term, the fifth term will be AR n minus 1. My A is 16. My R is 1 over 2. Raised to power n is 5 minus 1. That is 16 multiplied by 1 over 2. 5 minus 1 is 4. We have 16 multiplied by 1 raised to the power of 4 is definitely 1. 2 raised to the power of 4, that is 2 multiplied by 2, 4. By 2 again, 8 by 2, 16. So we have 16. So 16 cancels 16. We are left with 1. So the fifth term is 1. And it is, as you can see from the series, 1, 2, 3, 4, 5. This is the fifth term, 1. So we just proving that this thing is a geometric progression. So that is how to get the nth term of a given geometric progression. Or sometimes you'll be given the first term and the nth term, and the question will ask you to find the common ratio. Or you will have the common ratio and the nth terms, you'll be asked to find the first term. Let's take one example on that. The sixth term. The sixth term of a geometric progression is 32. The sixth term of a geometric progression is 32, and the first term is 1. Find the common ratio. The sixth term of the geometric progression is 32 and the first term is 1. Find the common ratio. The sixth term, T6, is ARn minus 1. So we are told that ARn minus 1 equals 32. Our n here is 6 and our A is 1. So A is 1 times R raised to the power 6 minus 1 equals 32. So 1 multiplied by anything is still the same thing. We have R raised to the power 6 minus 1, that is 5, equals 32. And if you apply our knowledge of indices here, this is R raised to the power 5. That means we are required to raise 32 or to raise a number to 5 and get 32. R raised to the power 5 is 2 raised to the power 5. 32 is 2 raised to the power 5. So that means the powers are now equal. And whenever the powers are equal like this, we also take the basis to be the same. So R equals 2. That means the common ratio of this geometric progression is 2. So we shall take more examples in the next lesson. Thank you.